All right, guys, so we're going to talk a little bit about this tent paper thing, right? And basically, we did the tent of paper, right? And when you blew through here, that made the paper go flat, right? So basically, we want to know what's going on there. And I asked you to explain in terms of that piece of paper. Obviously, the paper's holding it up, but I also asked you to explain how that kind of suggests that air is holding it up as well. So basically what's going on with this piece of paper is we have air pressure that's holding it up. And this is basically a static situation. So when this guy is sitting like this, all of the molecules in the air, theoretically, if you remember from chemistry, are pushing against this paper. Also though, they're pushing from inside the paper, so they're basically canceling each other out. When we blow through here, we take those molecules and we start moving them. So inside, the molecules are moving and pass through. So once we start moving those through, that's actually going to remove the particles from inside, essentially, which basically causes less pressure inside. If we have less pressure inside than we have outside, then outside pressure will win and it will collapse that little guy. Now, that's not terribly important to us, except that if we create less pressure inside, that means we have higher pressure outside. So we have less or low pressure, right, inside, and then we have high pressure outside. Basically what happens is we have high pressure on the outside trying to move toward the low pressure on the inside. And because it's doing that, the high pressure forces the low pressure away, essentially. So the high pressure is moving towards the low pressure. That's what we really need to kind of understand for what we're going to talk about in just a minute. So let me switch gears and come over here. We're talking about wind formation today, right? And we're trying to figure out how wind is formed. So here is this box of wind. I think I may have changed this box up on you a little bit, so if I did, forgive me. But basically, I just want to go through how this is a Bill Nye video. I'll actually post it on here so you can see it. But he has a box of smoke over here on the side too. This box is completely sealed, and what he's going to do is release the smoke into the box. And then I asked you some simple questions. I asked you where you thought, what you thought heated up fastest, right? So land is going to heat up pretty fast. The city's going to heat up really fast because it's made of concrete. I think that's what I did on your drawing. I think I switched these two. This is what Bill Nye's look like, so we're going to go with that. But if the city heats up faster, right? That means that air particles are expanding and they're starting to rise, right? So if air is rising, let's just look over here. If I have rising air, in terms of air molecules, I have fewer molecules down here, right? And if I have fewer molecules, that means I have less collisions. Pressure, you don't need to know this, but pressure equals force over a surface area. Particles are constantly colliding with each other. If these particles are colliding with each other, that produces a force. Just like a car would hit another car, that produces a force. And then if that is applied over a really small area, say put your foot on a nail, you'll feel that force immensely as high pressure. But then if you take that same force, your weight, and apply it over a bunch of nails, so you increase the surface area, that's going to decrease the amount of pressure so you don't feel it as much, right? So in the same case here, if I have fewer molecules, that means I have fewer collisions. That means I have less force. So if I decrease force, what happens to pressure? That decreases as well, right? So that means that I am at this point going to have low pressure, LP. Let me rewrite that for you here. Low pressure. Now, this is just kind of a crayon drawing of what's going on here. So bear with me on that. Don't think that this is like high level stuff yet. But basically, if this is low pressure and I have all of the air molecules they're basically moving up to that area, so I have more molecules here, that would create a higher pressure situation up here, right? Now, don't look at this as the air moving from low to high pressure, because we don't want to do that. What we want to do is this. Land will also heat up, right? So I should end up with a low pressure here. I have a higher pressure here. I have a low pressure in the city. I have a higher pressure in the city, right? Then ice, the opposite should be happening, right? So I should actually have air sinking here, right? So this should be producing a higher pressure here because it's moving in there, and then a lower pressure here moving there. Now, basically what's going on, these heat lamps are going to represent the sun, and they are going to heat up things. And remember, we talked about specific heat, which I'm not gonna quiz you on that, but this is where we know what heats up faster than other things. Remember, water has a high specific heat. So water, high specific heat. That means that it takes in a lot of energy and doesn't change temperature. Concrete and land are going to have a low specific heat, so they can change temperature really quickly. So that means they're going to heat up, and then the air above them would heat up, and it would start to move higher, right? It becomes less dense, so it floats. So we also talked about that in our pre-test. What floats? Warmer temperatures float in colder temperatures. So warm air rises, cold air sinks, right? So over the ice, air should be sinking. Over land, air should be rising. Over the water, it should probably be sinking compared to these two, compared to this guy maybe rising, right? So it's more of a comparison there. But basically what we're looking at, we have high pressure here, we have low pressure there, right? So if we look at this low pressure right here, and we look at this high pressure right here, we can now look at air trying to move across the surface in terms of high pressure moving toward low pressure. So in this case, high pressure is here, low pressure is right there. So the overall movement of air should be from high pressure to low pressure at the surface. So air movement at the surface goes from high to low pressure. All right. When it moves from high to low pressure, if I were to stick a flagpole or a boat or whatever it was from your quiz, right? If I stick a flag right here, right? We are going to see that flag, the wind is moving that way, so we will see that flag post up there to the left, right? So it would be waving to the left. Now, this would be surface level winds. So these are winds at the surface. Air is moving from high pressure to low pressure. How did it happen? First of all, I needed the sun, right? So the sun heats the earth. 2, land gets hotter than water. Air rises above land. I don't know if I like this board thing. It's interesting. So that's rises above land, right? And then third, rising, surrounding air replaces air that rose, which we said was high pressure moves toward low pressure, right? So if you can imagine, I showed you those two videos about laminar flow versus turbulent flow. All of this is speaking in terms of, like, we're looking at laminar, right? It's pretty, it's fun to look at, right? It's easy to see. But in the real world, really, this would be turbulent. This wouldn't be as neat and crayon of a drawing. We would actually have a lot of different interactions going on right here. So, you know, it's not gonna move straight over there perfectly because you got some heating here, some cooling here, some, you know, things that are going on. So it's not gonna be this perfect movement of air like we see in Destin's video of laminar flow. All of the things that we're gonna be talking about here, we're gonna talk in terms of laminar. Nice, easy, packaged, sweet, looks easy to see, but in real life, there's so many other variables at play that it's actually almost always going to be turbulent compared to what we're looking at here. So first thing we're looking at that we just need to understand is that pressure is what is going to drive the wind. But what creates the pressure? It's going to be temperature differences. What causes those temperature differences? The sun heating the earth, and the earth being composed of different types of substances. And if we can do that, that creates temperature differences, and those temperature differences then cause pressure differences, which then cause air to move from one location to another. So that would create our surface winds here. We will also end up with upper level winds. These would be rising winds and sinking winds, right? But then across the top, we have high pressure here, we have low pressure here. So the overall flow in this box would go across the top. So this would be our upper level wind. And it is doing the exact same thing that our surface level winds were doing, so we don't really need to talk too much about those. But do note that your upper level winds, the higher up you go, the colder it gets in the atmosphere. So these winds, or these air molecules, as they rise, are going to start to contract and cool. When those start to contract and cool, then they are going to want to sink again because they become more dense. When they want to start sinking again, right, then the cycle just continues. This whole thing right here is called, I'm gonna go ahead and erase all of this. This whole thing right here, we have where warm air rises, right? And we can call this fluids if we want, because this happens in water too, but warm air rises, and then cold air sinks, right? So sinks, I forgot to write rises over here, I'll write rises, right? This whole guy right here is called a convection cell. And you learned about those in physics or chemistry. I used to teach them in chemistry, also taught them in physics. But basically these convection cells are created by sun's energy heating up the earth. That air will then rise, cold air will sink, fill in its place. So right in here, right in here, we would get our surface wind. And then up here would be our upper level winds. And then in weather terms, when cold air is sinking, usually that is becoming a little bit more stable. So it's usually called a high pressure system. And then when it rises, it's becoming less stable. You can create storms, and that is going to be called your low pressure systems. So I think I said that right. So basically when warm air rises, that gives us the ability to make clouds, and that gives the ability to make our weather angry, and this would be associated with a low pressure system, right? Now, what is it creating? It's actually creating a low pressure at the surface, a higher pressure at altitude, right? And then over here, basically this sinking air would actually cause those clouds to go away. The sun would be shining brightly, and it would be really hard to produce clouds, and that is going to be called a high pressure system. I'm going to stop it there. So no low pressure, high pressure. Sun heats the earth, air rises, creates low pressure at the surface. High pressure would then move into that. The movement of the air across the surface is going to be called wind. Thanks. Look forward to talking to you soon.